Hi everyone, welcome back. So today we're going to be walking through another Codewars problem. This is the problem count odd numbers below n, and it is an 8 KYU. So it's a fairly simple problem, but a little bit tricky as we'll walk through. So given a number n, return the number of positive odd numbers below the number n. So it's saying it's easy, and so I'm going to give you the solution, but I'm also going to give you what I first started off with and why it was failing. So essentially what I realized throughout, and maybe let me just first start with the code that I began with. So essentially what I initially had was something like this. So I was doing a counter because we wanted to count the numbers below in that are odd and positive. So setting the counter equal to 0 and saying for number in range 0 to n. So we're going from 0 to n, technically n minus 1, because the end part of range is exclusive. But anyway, so kind of iterating through each of those numbers and saying if the number was divisible with a modulo operator by 2, and it did not equal 0. So basically saying the inverse of if it's not even, because we know to check even of doing in modulo 2 equals 0 is even. So basically if it's odd, then doing counter plus equals 1, and then returning the counter. And I want to show that this actually works for the initial test case. So you can see here, but if I attempt this on all of the test cases, which you can see here, it's testing this really large number of 15,000. Eventually what's going to happen here is this is going to essentially time out of memory, so it's just not efficient enough, and that's one thing that I'm noticing with Python. So really when it said it's easy, it's actually easy. It's basically making you think of it in a different manner, and so what you can actually do is just in double / which is going to be the floor math rounding. So basically what this is going to say, let's say we have a number 5 divided by 2 is going to be 2.5, but because we have the double slash, we're going to round down, so the floor rounding, so that would be 2, which is correct. If we were given the number 5, the number of odd numbers below 5 are 1 and 3, so that's 2. So we'll test this, and I did not return this, so that's why that's not working. But return that and then attempt that and see it's passed. Fairly simple. So a little bit tricky here, but yeah, glad we were able to figure it out.